Let's talk about the building interior. The most common problem that homeowners experience is water intrusion in the form of outside water penetration and plumbing leaks. Inside the house, always look for signs of water intrusion or material deterioration that may indicate underlying problems in the structural, electrical, plumbing, or HVAC systems. Consider hiring an inspector who is trained in the application of infrared thermography because thermal imaging is an excellent tool to use in the search of water intrusion. Basement and crawl space. The basement or crawl space is often the most revealing area in a home and usually provides a general picture of how the entire structure works. In most cases, the structure is exposed overhead, as are the HVAC distribution system, plumbing, supply and drain waste vent lines, and the electrical branch circuit wiring. Moisture intrusion. One of the most common problems in small residential structures is a wet basement. You should monitor the walls and floors for signs of water penetration, such as dampness, water stains, peeling paint, efflorescence, and rust on exposed metal parts. In finished basements, look for rotted or warped wood paneling and doors, loose floor tiles, and mildew stains. It may come through the walls or cracks in the floor, or from backed up floor drains, leaky plumbing lines, or a clogged air conditioner condensate line. To properly correct a moisture problem, you must determine the source of the moisture. There's no point in cleaning up or wiping up a problem without investigating the source of the problem first. If moisture appears to be coming in through the walls, check roof drainage systems and grading around the exterior of the building because the problem could be as simple as a clogged gutter. Check the sump pump, if there is one, to be sure its discharge is not draining back into the basement. Look for unprotected or poorly draining window wells, leaking exterior faucets, and signs of leakage in the water supply line near the building. Check the elevation of an earthen floor in a crawl space. If the water table is high or the drainage outside of the building is poor, the crawl space floor should be below the elevation of the exterior grade. If the basement or crawl space is merely damp or humid, the cause may simply be a lack of adequate ventilation. The ventilation could be checked by measurement and calculation, comparing the free area of vents with the floor area of the crawl space. The ratio of free vent area to crawl space should be 1 to 150 in a crawl space with an exposed earth floor, and 1 to 1,500 in a crawl space with a vapor barrier over the earthen floor. If the calculated ratio is less, consider adding ventilation, particularly in hot and humid climates, and especially if moisture is present. Check the location of the vents through the foundation or the exterior wall. There should be one vent near every corner of the crawl space to promote complete air movement. The vents should have screens with corrosion resistance mesh. Fungal and insect infestation. Always keep an eye out for signs of fungal growth, particularly in unventilated crawl spaces. A certified home inspector could be hired to check annually all foundation walls, piers, columns, joists, beams, and sill plates for signs of termites and other wood-destroying insects. Thermal insulation. If you have access to the space above the unheated basement or crawl space, examine the amount and type of insulating material installed, if any. Determine the amount of insulation that is recommended for the space and whether additional insulation can or should be added. Check for adequate vapor barrier. If you live in a cold climate, the vapor barrier should be installed on the warm interior side of the wall. If you live in a warm climate, the vapor barrier should be installed on the exterior side of the wall. Let's go to interior spaces. Monitor the following. Walls and ceilings. Check the general condition of all surfaces and don't fret over cosmetic imperfections. Be aware of the signs of water intrusion into the building, including exterior water penetration and interior plumbing leaks. Look for cracks in peeling paint or wallpaper. Look for sags and bulges in plaster or drywall. Gently tap and push on areas of plaster. If an area sounds hollow or feels flexible, it's a good indication that the plaster is separated from its backing. If such areas are found, it may be best to replaster or overlay the walls or ceiling with wallboard. Monitor walls and ceiling cracks. The cracks are usually caused by building settlement, deflection, warping of wood structural elements, or small seasonal movements of building components due to temperature and humidity variations. Seasonal movements will make some cracks regularly open and close, and these may be filled with a flexible, paintable sealant, but otherwise cannot be effectively repaired. Cracks due to settlement, deflection, or warping can be repaired if movement has stopped, as is often the case. Large wall and ceiling cracks may indicate structural problems. Nail pops. Homeowners often find nail popping, joint cracks, and other signs of minor cosmetic issues, such as rust stains at fasteners and corner beads. You can check paneled walls by pushing or tapping on the paneling to determine if it is securely attached or has become loose in some way. Veneers can become delaminated. If the paneling is obviously not original to the house, try to look behind it to see what problems may be covered up. Homeowners should lift suspended ceiling panels and look above them. Check the condition of the original ceiling, if one exists. Tiled ceilings should be examined similarly. On top floors, inspect for ceiling penetrations that may form thermal bypasses to the unconditioned spaces above. Interior doors. Monitor the condition of doors and door frames, including the interior of entrance doors and storm doors. Check the hardware for finish, wear, and proper functioning. Sticking doors or out-of-square frames may indicate building settlement. Windows. Look at the window sashes and frames for damage and deterioration. Check for a good fit and apparent weather tightness. When casement windows are open, they are easily damaged by wind, and hinge damage may keep them from closing properly. Casement hardware should operate smoothly and easily. Older double-hung windows may have old sash cords and weights that may break. Every once in a while, open windows above the ground floor and check their exterior surfaces, frames, seals, awnings, and shutters, if any. Safety glass. There are many areas in a house that require safety glass. These areas are hazardous because of their frequent impact by the home's occupants. Glazing installed indoors is of particular concern because of the increased probability of accidental impact while operating the doors. A person may often push against the glazed portion of a door in order to open it. A large piece of glass installed along a travel path where no barrier is provided is a potentially dangerous area. If the glass is safety glass, it will have a permanent label on it in a corner. Ventilation. Habitable rooms should be provided with operable windows. Their required opening size is a percentage of the floor area, usually around 4%. A mechanical ventilation system can be provided in lieu of this requirement. Egress. Basements in every sleeping room should have at least one operable emergency escape and rescue opening that opens directly into a public street, public alley, yard, or court. Basements that have one or more sleeping rooms should have an emergency egress and rescue opening installed in each sleeping room, but this is not required for adjoining areas. The sill height of the emergency escape and rescue opening should not be more than 44 inches above the floor. Because many deaths and injuries happen when occupants are asleep at the time of a fire, this standard requires that basements in all sleeping rooms have doors or windows that can be used for rescue or escape in an emergency. During a fire, the normal means of escape will most likely be blocked. If the emergency and escape rescue opening has a sill height below ground level, a window well should be provided, and the window well should have a horizontal area of at least 9 square feet, with a minimum horizontal projection and width of 36 inches, with the exception of a ladder encroachment into the required dimension. If an emergency escape window is located under a porch or a deck, the porch or deck should allow the window to be fully opened and the escape path should be at least 3 feet in height. Closets. Closets should have a clear depth of at least 24 inches. And watch out for any improperly installed light fixture. A closet needs the proper type and location for the light fixture. A light positioned close to a shelf presents a fire hazard. Electrical outlets and lighting. Generally speaking, each wall should have at least one wall outlet, and each room should have one switch-operated outlet or overhead light. When operating light switches, look for dimmed or flickering lights that may indicate electrical problems somewhere in the circuit. Also, check the light switches for sparks or arcing when the switches are turned off and on. Feel the light switches for overheating. Switches that are worn should be replaced. When a light does not turn on, even after the bulb has been replaced, it will likely be the result of a bad switch. HVAC source. For every room in the house, there should be a heating, cooling, or ventilating source. If there is a warm air supply register but no return, make sure the doors are undercut 1 inch for airflow. Skylights. Monitor the undersides of all skylights for signs of leakage and water damage. Skylights are notorious for leaking water and causing water stains and damage. Firewall. It is common for a fire to start in an attached garage. The fire may grow unnoticed by the occupants and become a significant hazard. Therefore, a minimum amount of fire protection is needed. The door construction and fire rating of the door is important to know. The door between an attached garage and a home should be a solid wood core door, not less than 1 3/8 inches thick, a solid or honeycomb core steel door, not less than 1 3/8 inches thick, or a 20-minute rated, fire-rated door. In many jurisdictions, a self-closing device on the door may be required. The entire door assembly may have to be fire-rated. A direct opening between an attached garage and a sleeping room is not permitted. That opening would be hazardous. There should be at least a 1/2 inch drywall gypsum board applied to the garage side to separate the garage from the residence and its attic space. A garage located below a habitable room should be separated by a 5/8 inch Type X drywall gypsum board or equivalent. This standard requires a minimum level of fire protection from the garage to the home. It allows the occupants time to escape. The separation also restricts the spread of fire from the garage to the home until the fire can be controlled and extinguished. Bathrooms. The plumbing. Obviously, you should always want to check for water drips and leaks. Check the operation of the lavatory, that's the sink, the toilet, tub, and shower. A common problem in bathrooms is water leakage around tubs and showers. It's a good idea to look up and check the ceiling below each bathroom for signs of water or to spot the development of a major water leak. If the toilet is not a water-saving fixture, consider replacing it with a water-saving toilet that has a 1.6 gallon flushing capacity. Pressure-assisted toilets use water pressure to compress air in a tank that makes the 1.5 to 1.6 gallon flush very effective in cleaning the fixture bowl and preventing buildup in the soil pipe. Check the water traps for drips. Trap pipes may be of older materials such as the soft brass with a chrome coating. It could deteriorate and weaken over time. Check the toilet for wobbling. If the toilet becomes loose and starts to wobble on the floor, a new wax seal may be needed. A faulty shower pan may go undetected for decades until a major water leak develops. Monitor the ceiling below all showers for signs of water leakage. Electrical. Wherever possible, switches and outlets should not be within arm's reach of a tub or shower. Ground fault, circuit interrupters, GFCIs, should be installed at the bathroom's electrical outlets. the GFCIs, should be tested every month. The tub and shower. Monitor the tub and shower enclosures. The glass or glazing, if they're installed, should be safety glazing. Ceramic tile. Push and pound on the tiles with your hand and check for loose tiles. Pull on the soap dish. Nothing should be loose or wiggly. Periodically, watch for tiles that become damaged or loose, or tiles that become scratched, pitted, or dulled by improper cleaning. Monitor the condition of all grouted or caulked joints. If a portion of the tile is defective or missing, the tile may need to be replaced. Open cracks in the tile grout may allow water to penetrate behind the tile and cause damage. Plumbing access panels. Open up the plumbing access panels every once in a while and check for developing water problems. If there isn't a plumbing access panel installed behind the shower or tub, one should be installed. Ventilation. The bathroom should be ventilated by either a window or an exhaust fan. Poor ventilation will cause mildew to form on the ceiling and walls. If there's an exhaust fan, it should be properly ducted to exhaust to the outside. The kitchen. The kitchen plumbing. All by themselves, plumbing connections could develop leaks. Checked often for water drips and leaks in both the supply and drainage lines. When operating the disposal and dishwasher, listen and watch for smooth operation. Kitchen counters and cabinets. Over time, cabinet doors and drawers can lose their smooth operation, and wall cabinets may become insecurely attached to the wall or other cabinets. Electrical. All kitchen counter receptacles should be protected by ground fault circuit interrupters, GFCIs. Separate circuits should be installed for each major appliance as follows: the refrigerator on a 20 amp, dishwasher on a 20 amp, garbage disposal on a 20 amp, the range 40 to 50 amp. All electrical appliances should be able to operate simultaneously, including exhaust fans, and run steadily without overloading their circuits. Kitchen ventilation. The kitchen exhaust fan and range hood should be ducted to the outside and not to a cupboard, attic, crawl space, or wall. A recirculation range hood fan is acceptable, but ideally, all exhaust fans discharge and terminate outside. Maintain and clean the filters. Ducts, hoods, and filters should be free of grease buildup. Storage spaces. All closets and other storage spaces should be properly lit, properly ventilated, and kept clean to prevent vermin infestation. Stairs and hallways. A light at the stair and hallway. All interior and exterior stairways should have a means to illuminate the stairs, including landings and treads. Interior stairways should have a light located at each landing, except where a light is installed directly over each stairway section. Public stair and hallway lights in multifamily buildings should be operated from centralized house controls. Smoke detectors. Periodically check the operation of all smoke detectors by pushing their test buttons. Stairs and hallways are the appropriate locations for smoke detectors. They should be located on or near the ceiling, near the heads of stairs, and away from the corners. Current standards require a smoke detector just about everywhere, including each sleeping room and every level of the house, and in hallways adjacent to the sleeping rooms. Structural integrity of the stairs. All stairs must be kept structurally sound. Examine basement stairs where they meet the floor and where they are attached to the floor joists above. Stair handrails and guardrails. You can check a railing stability and its fastenings by shaking it vigorously. Handrails are normally required to be 34 to 38 inches above the stair nosing on at least one side of the stairs with 3 or more risers. Guardrails are required on open sides of stairways and should have an intermediate rails that do not allow the passage of a sphere 4 inches in diameter. Stair treads and risers. All treads should be level and secure. Riser heights and tread depths should be as uniform as possible. As a guide, stairs in new residential buildings must have a maximum riser of 7 3/4 inches and a minimum tread of 10 inches. Stair width and clearance. Stairs should normally have a minimum headroom of 6 feet and 8 inches and a width of 3 feet. Laundry and utility rooms. Laundry room. Watch for leaks and kinks developing at plumbing connections to the washer. Protect the electrical or natural gas connections to the dryer. Inspect dryer venting and make sure it exhausts to the outside and is not clogged or restricted. A gas dryer vent that passes through walls or combustible materials must be made of metal. The clothes dryer exhaust. A clothes dryer exhaust poses a different problem than other exhaust systems because the air is moist and carries lint. The exhaust of a dryer must vent outside and not discharge into an attic or crawl space because the wooden structural members could be affected. Exhaust vents should have a backdraft damper installed to prevent cold air, rain, snow, rodents, and pests from entering the vent. The length of a clothes dryer exhaust ensures that the dryer exhaust blower will be able to push sufficient air volume to take away the moist air and the lint. The length can be increased only when the make and model of the dryer is known, or when an approved blower fan circulation is provided. The maximum length of a clothes dryer exhaust duct should not be greater than 35 feet from the dryer location to the wall or roof termination. For each 45-degree bend, the maximum length of the duct is reduced by 2.5 feet. For each 90-degree bend, the maximum is reduced by 5 feet. The maximum length of the exhaust duct does not include the transition duct. Screens are not permitted on the clothes dryer exhaust vent because they can trap lint and debris and pose a fire hazard. The furnace room. Rooms containing fuel-burning equipment should not be located off a sleeping room in a single-family residence and must be in a publicly accessible area in a multi-family building. Check local code requirements for applicable fire safety and combustion air criteria. Fireplaces and flues. Fireplace. Each fireplace and flue in a house should be inspected by a certified chimney sweep every year. Every time prior to starting a fire, check the firebox for deterioration or damage. If there is a damper, check its operation. Make sure you open the damper prior to starting the fire. If smoke starts to billow out from the fireplace, the damper is closed or there's a major blockage in the flue. Hearth. The hearth should be of adequate size to protect adjacent combustible building materials. For older fireplaces, the minimum depth of the face of the fireplace is 20 inches, with a width that extends 1 foot beyond the fireplace opening on either side. Flues. The flue lining in a masonry chimney should be inspected by a professional every year. It could be checked by your HVAC technician or a certified chimney sweep. The flue should be tight along its entire length. Linings should be intact, unobstructed, and appropriate for the fuel type. An obstructed flue can usually be opened by a chimney sweep, but consult a chimney expert if the integrity of the flue is in doubt. Unlined chimneys should be updated with the installation of metal liners. Smoke pipe connections. Every once in a while, check that the smoke pipes from furnaces, water heaters, stoves, and related devices are tightly connected to the chimney. Ash dump and pit. If the fireplace has an ash dump at the bottom of the firebox, check the operation, fit, and condition of the door, and check the shaft to the ash pit to be certain it is unobstructed and not overflowing with ashes. If the chimney has an ash pit, check the operation, fit, and condition of the pit access door. The fit should be tight enough to prevent dust and ash from escaping. Cleaning the ashes is part of a regular maintenance of the fireplace. Attics, roof trusses, and vents. An attic is defined here as an unconditioned space between the roof and the ceilings or walls of the other rooms of the house. In small residential buildings with pitched roofs, attics are usually partially or fully accessible. In buildings with low-slope roofs, they may be inaccessible or virtually non-existent. Roof leaks. Look for signs of and monitor water leakage from the roof above and try to locate the source. This may be difficult to do beneath built-up roofs or beneath loosely laid and mechanically fastened single-ply roofs, since water may travel horizontally between layers of roofing materials. Attic ventilation. Signs of inadequate ventilation are rusting nails in roof sheathing, soffits, and drywall ceilings, wet or rotted roof sheathing, and excessive heat buildup in attics. Adequate attic ventilation can be measured by calculating the ratio of the free area of all vents to the floor area. The free area of vents is defined as the clear, open area. If a vent has an insect screen, its free area is reduced by half. The free vent area to floor area ratio should be 1 to 150. If the calculated ratio is less, consider adding ventilation, especially in hot and humid climates. When an attic also contains an occupied space, check that the ventilation from the unconditioned, unoccupied areas at the eaves is continuous to the gable or ridge vents. Also check that the free area of eave vents is approximately equal to the free area of ridge or gable vents. If ventilation appears to be inadequate and additional vents cannot be added economically, consider adding mechanical ventilation. Rafter space ventilation. Most homes with low slope roofs and some with pitched roofs do not have attics. Instead, these structures have ceilings at the bottom of the joists, rafters, or trusses, and the truss space and the space between each joist or rafter and above the ceiling need ventilation. At ridge, cornice, eave, or soffit vents, install insect screens. Vents and birds. Make sure ventilation openings are clear of dirt and debris. At larger ventilation openings on a building's exterior, where louvered grills are used, such as at gables, check for the presence of 1/2 inch square 14 or 16 gauge aluminum mesh bird screen. If there is none or it's in poor condition, consider having new bird screen installed. Thermal insulation. Every homeowner should know the amount and type of insulating material installed in the house. For cold climate zones, the insulation faced with a vapor barrier should be installed face side down and the vapor barrier closest to the conditioned space. The vapor barrier should be properly located between the ceiling and the first layer of insulation. Determine the proper amount of insulation to the attic and whether additional insulation is needed. If attic insulation is placed against the roof sheathing, a ventilated airspace between the insulation and the sheathing will be needed. If there is no airspace, check for the presence of moisture and deterioration of the sheathing or rafters. Ensure that insulation is held away from the recessed light fixtures and look at the spaces around vents, stacks, ducts, and wiring for thermal bypasses. Inspect attic doors or access hatches, heating or cooling ducts that pass through the attic, and whole house attic fans for thermal bypasses. Check the local jurisdiction for thermal resistance or R value requirements. Plumbing stacks and exhaust ducts. All plumbing stacks should continue through the roof and should never terminate in the attic. The stack pipes should not be loose, broken, or damaged. Exhaust ducts should not be kinked, broken, or damaged and should not terminate in the attic, but either continue through the roof, gable, or wall. Whole building thermal efficiency tests. Several whole building tests can be performed to help evaluate the thermal efficiency of the building envelope. A certified home inspector could be hired to perform a home energy inspection or assessment of the home. A building depressurization test can be used to determine the rate of air infiltration and exfiltration. The test is particularly useful for tightening up an older building. A tracer gas test may be used. A handheld infrared camera can be used to detect building hotspots due to interior air leakage or excessive heat loss through an uninsulated building component. This test should be performed in cold weather when the building is heated. The greater the differential between the inside and outside temperatures, the more accurate the results. Thermography inspections should be performed by an energy specialist, a certified home inspector, a home energy inspector, or others with the proper training and equipment. Sound transmission. The floors and walls between dwelling units should have adequate sound transmission control using the current building code for guidance. Walls and floors that separate dwelling units in two-family residences and walls that separate townhouses should have an adequate sound transmission control. Asbestos. Asbestos is a naturally occurring fibrous mineral used in many construction products. It is considered to be a carcinogen. Asbestos has been used in sealant, putty, and spackling compounds, in vinyl floor tiles, backing for vinyl sheet flooring, and flooring adhesives, in ceiling tiles, in textured paint, in exterior wall and ceiling insulation, in roofing shingles, in cement board for many uses including siding, in door gaskets for furnaces and wood-burning stoves, in concrete piping, in paper, millboard, and cement board sheets used to protect walls and floors around wood-burning stoves, in fabric connectors between pieces of metal ductwork, in hot water and steam piping insulation, blanket covering, and tape, and as insulation on boilers, oil-fired furnaces, and coal-fired furnaces. The use of asbestos was phased out in 1978, but many older houses contain asbestos-bearing products. Products containing asbestos are not always a health hazard. The potential health risk occurs when these products become worn or deteriorate in a way that releases asbestos fibers into the air. Of particular concern are those asbestos-containing products that are soft, that were sprayed on or troweled on, or that have become crumbly. The Environmental Protection Agency of the United States believes that as long as the asbestos-bearing product is intact, it is not likely to be disturbed, and it is in an area where repairs or rehabilitation renovation will not occur, it's best to leave the product in place. If it is deteriorated, it may be enclosed, coated, or sealed up, it's called encapsulated, in place, depending upon the degree of the deterioration. Otherwise, it should be removed by a certified professional. A certified environmental professional could perform an inspection and make the decision whether to enclose, coat, encapsulate, or remove the deteriorated asbestos-containing products. Testing by a qualified laboratory, as directed by the environmental professional, may be needed in order to make an informed decision. Encapsulation, removal, and disposal of asbestos products may be done by a qualified asbestos abatement contractor. Lead. Lead has been determined to be a significant health hazard if ingested, especially by children. Lead damages the brain and nervous system, adversely affects behavior and learning, slows growth, and causes problems related to hearing, pregnancy, high blood pressure, the nervous system, memory, and concentration. Lead-based paint. Most homes in the U.S. built before 1940 used paint that was heavily leaded. No more than half of the homes built between 1940 and 1960 in the United States are believed to contain heavily leaded paint. In the period from 1960 to 1980, fewer homes used lead-based paint. In 1978, the U.S. Consumer Product Safety Commission set the legal limit of lead in most types of paint to a trace amount. As a result, homes built after 1978 should be nearly free of lead-based paint. In 1996, the U.S. Congress passed the final phase of the Residential Lead-Based Paint Hazard Reduction Act, Title 10, which mandates that real estate agents, sellers, and landlords disclose the known presence of lead-based paint in homes built prior to 1978. Lead in paint. Lead-based paint that is in good condition and out of the reach of children is usually not a hazard. Peeling, chipping, chalking, or cracking lead-based paint is a hazard and needs immediate attention. Lead-based paint may be a hazard when found on surfaces that children can chew or that get a lot of wear and tear, such as windows and window sills, doors and door frames, stairs, railings, banisters, porches, and fences. Lead from paint chips that are visible and lead dust that is not always visible can both be serious hazards. Lead dust can form when lead-based paint is dry scraped, dry sanded, or heated. Dust also forms when painted surfaces bump or rub together, such as when windows open and close. Lead chips and dust can get on surfaces and objects that people touch. Settled lead dust can re-enter the air when people vacuum, sweep, or walk through it. If the building is thought to contain lead-based paint, consider having a qualified professional check it for lead hazards. This is done by means of a paint inspection that will identify the lead content of every painted surface in the building and a risk assessment that will determine whether there are sources of serious lead exposure, such as peeling paint and lead dust. The risk assessment will also identify actions to take to address these hazards. The U.S. federal government has standards for inspectors and risk assessors. Some states may have standards in place. Call local authorities for help with locating qualified local professionals. Do-it-yourself home tests should not be the only method used before doing rehabilitation or to ensure safety. For more information on lead-based paint, consult the HUD Office of Lead Hazard Control. Lead in water. Lead in drinking water is a direct result of lead that is part of the plumbing system itself. Lead solder was used in pipe fittings in houses constructed prior to 1988. Lead has been used in plumbing fixtures, such as faucets, and in some older homes, the surface water pipe from the main street to the house is made of lead. The transfer of lead into water is determined primarily by exposure, the length of time that water is in contact with the lead. Two other factors that affect the transfer are water temperature, hot water dissolves lead quicker than cold water, and water acidity. Soft water is slightly corrosive and reacts with lead. The current federal standard for lead in water is a limit of 15 parts per billion. The only way to find out whether there is lead in the house's water is to have the water tested by an inspector and an approved laboratory. If there is evidence of lead in the system, consider having the water tested for lead. If the house has a water filter, check to see if it is certified to remove lead. Radon gas. Radon is a colorless, odorless, and tasteless gas that is present in varying amounts in the ground and in water. Radon is produced by the natural radioactive decay of uranium deposits in the earth. Prolonged exposure to radon in high concentrations can cause cancer. The U.S. EPA has set guidelines for radon levels in residential buildings. Airborne radon. The EPA recommends that mitigation measures be undertaken in residential buildings when radon concentrations are 4 picocuries per liter of air and above. The The radon concentration in a house varies with time and is affected by the uranium-radium content in the soil, the geological formation beneath the house, the construction of the house, rain, snow, barometric pressure, wind, and pressure variations caused by the periodic operation of exhaust fans, heating systems, fireplaces, and attic fans and range fans. Radon concentrations are variable and may be high in one house and low in an adjacent house. To determine if a house has a radon problem, it must be tested. The long-term test is the most accurate method of determining the average annual radon concentration. However, because time is usually limited, there are short-term tests that have a testing period of 3 to 7 days. Radon tests are available from most home hardware stores or through a radon testing service company. Radon in water. A home's domestic water supply from its well can contain radon. There are locations with well water containing 40,000 picocuries or more. The health problems from drinking water with radon are insignificant compared to breathing airborne radon, but radon can be released into the air when water is run into a plumbing fixture or during a shower. It takes a high concentration of radon in water to produce a significant concentration in the large volume of air in a house. Private well water testing is normally not part of a radon test. Therefore, if the house has a private well, consult the local health department to determine whether water testing in the house's area is recommended. Annual testing of the water quality of a private well is considered part of a regular home maintenance plan. Many home inspectors perform water quality sampling. If a building is found to have a radon problem, consult a certified radon mitigation contractor. Tornado safe room. If a building is located in a tornado risk area, it should have a tornado shelter or safe room, and it should be structurally adequate. According to the INTRNCHI Home Inspection Standards of Practice. At the fireplace, the home inspector should open and close the damper, check the hearth, and report major deficiencies. The inspector is not required to inspect the flue or vent system. Inspectors do not operate inserts or ignite pilot flames. The inspector is not required to operate any appliance. Environmental hazards such as lead and radon are beyond the scope of a home inspection. The home inspector should flush toilets and run water at all the plumbing fixtures. The inspector should report any present conditions or clear indications of active water penetration he or she observes. Predicting water intrusion from either groundwater or the plumbing system is beyond the scope of a home inspection.